Okay, so we're on the 13.4 notes. You can use a highlighter, but you don't have to. So I am just going to use a highlighter real quick to show you guys what the difference is between what we did yesterday and what we did today. So yesterday, I made a big deal about the slant height, and it's on the side of the shape. Today, it's just how tall is the shape. So what is the height of this pyramid? How tall is it? So that's what goes under H. Here's our formula. It's the exact same formula as the volume of prisms and cylinders, except we divide it by 3. You could also say this, 1/3 BH. That's also the same thing. It doesn't matter which one. But my capital B is going to just be the area of that base, which it is a triangle. So my capital B is going to be base times height divided by 2. So if I look at my triangle, I'm like, where's my right angle? It's right there. The two things that touch that right angle are the 3 and the 4. So, this right here, if it gave us this side, that 5, we wouldn't even need it. We don't need the perimeter at all. But this is going to be 6, because 3 times 4 divided by 2 is 6. And then you have everything you need. You're just plugging it in. So base times height divided by 3 is 6 times 6 divided by 3, which is 12. So 12 units cubed. That means there's 12 1 by 1 by 1 little cubes that can fit inside this pyramid. All right, let's look at this one. So this is a rectangular pyramid. The base of this it's pretty easy. It's just 8 times 10. So it's 80. Because it's, so we're actually going to use trig here because we only have, if we had 2 of the 3 sides, we could use Pythagorean theorem. But in this case, we only have 1 of the sides. And you may look at it and think, what is this side? I don't know what it is. But 10 is the length of that whole side. Yeah. So it's half of that. So it's going to be 5. Oh no. It's Thursday. Never mind. But we will talk about that later. All right. My height. So we are looking for this height. We're not looking for the slant height today. So we don't care about the hypotenuse. So we are going to use tangent. All right, why did I set it up like this? 60 is my angle. X is on the opposite side, and you may be like, you are putting your own X on there. Like, no, nothing on that picture tells you that you need to solve for X other than you knowing that you need the height. All right, and then when you type that in your calculator, you're going to get this number, which we're going to just leave this in our calculator. Stop. So, base times height divided by 3. So we're going to round at the very end. We're going to put like this whole thing in the calculator. I'll show you guys. So the area of the base is 80. Oh, actually, I'm going to do it like that. So 80 times, and I'm going to go back up here, and I'm going to grab this. I'm going to highlight this and grab it because we don't round until the very end. Oh, divided by 3, not 2, like I did. So 80 is our area of our base times that height divided by 3 is 230.9. All right. Love that. All right. Let's look at our capital B here. Okay, there were a lot of questions on this type of problem, which I think this type of problem was number 9 on our assignment yesterday. So what you're going to do is just make sure you realize this is a regular polygon. And make sure you can see that your apothem is 2. Your perimeter of your base, there's 5 sides. Each of those sides is 3 units long. So where are these numbers coming from? This is 3. There's 5 of them. So to figure out the area of the base, you need the apothem and the perimeter. You already have the apothem, which is so nice. You don't have to use trig. So we're going to use 15 write that. And when you plug that in, you get 15 for the area of the base. Height is 7. So how tall is your shape? It's 7 units tall. So you're going to get 35 for this one. One thing I want to point out, it's going to say this on here, area of the base times height. Write this on here as well. Or, okay, this is always pi r squared for a cylinder. This is always pi r squared for a cylinder. That's why it's written like this here. But on the formula chart, it's written here because it's literally the same formula that we just did for a pyramid. What is your question? We will get there. So this we're going to use Pythagorean theorem. There are some problems that you're going to have to use Pythagorean theorem today. Make sure you're familiar with that. Also, I'm telling you right now, if questions are missed on the test, a lot of times it's not because you don't know how to solve for it. It's that you forget that surface area needs that slant height, that L. Height needs just the normal height, or volume needs just normal height. So if you're going to miss one on the test, it's probably, a lot of times it's going to be this. This is one of the more higher missed questions because it looks like you have all the things that you need, but you actually don't. You have slant height, but you need normal height. So we've got to use Pythagorean theorem to solve for that. This is the diameter. The radius is 9. All right, so if my radius is 9, I'm going to write that in right there. I have everything I need but the height. In order to find that height, we've got to use Pythagorean theorem. Why can we use Pythagorean theorem now, whereas we had to use trig before? No. But 9 squared plus b squared equals 15 squared. Therefore, we are going to subtract. Make sure you don't do 15 minus 9. So 9 squared. 15 squared minus 9 squared is 144. So that's where we're going to get our height. Okay. You won't have to do this for all the problems. You have to be able to identify, because it's not going to be like written in bold letters anywhere saying use Pythagorean theorem to solve this. It will just give you a picture, and you have to know what you need to use, and you have to figure out how, do I use trig, do I use Pythagorean theorem to find what I need. So, make sure that you're on the right page. So r squared is 9 squared, the height is 12. And then we can just type that into the calculator. I will say on Delta Math today, it calls for some of them in terms of pi. So make sure you know how to do that. If it asks for it in terms of pi, it wants this answer. If it wants it, or if it asks for it, the other way, to the nearest tenth, it wants this answer. Yes, because they're all being multiplied. If there was some addition, it would get kind of weird, and you'd have to put it in the exact spot. But since these three numbers are just being multiplied, it doesn't matter where it goes. Yeah, it's like that number, but it never ends, so it's correct. Because 3.14 is different than 3.141592, it's like slightly different. And it could change. I don't know, you should write a paper on it or something. Research it. Alright. This last one right here, so you won't see this as much. You can absolutely use trig if you want, but if you remember those 45, 45, 90 relationships, you can remember that the radius is 3 here. So if that radius is 3, how do we know that? Well, the whole thing is 6. How do I know that?
two legs are the same because the angles are like pointing at the two legs, and the angles are the same. So the two legs would be the same.
The radius is not 6. The diameter is 6. So the radius is 3. So let me explain that like in a different way. This is a 45, 45, 90 triangle. So you can think of it as in root 3, the whole side right there is 6. If you're like, I have no idea how the heck to do that, just use trig. It's not a big deal. Like, it's going to be 45, tangent of 45 equals 6 over the diameter. Type it into the calculator, you're going to get 6. If you can't, it's just those special right triangles are shortcuts to be able to do that, but trig is another thing. Can what? Yeah, and it's going to be the same. It's actually, if you do 6 times 45, or tan 45, or 6 divided by tan 45, it's the same. You get the same thing. That's the only one that does like that because the 45s are equal. All right, and now you have everything you need. So pi times 3 squared times 6 equal, or divided by 3 equals, so 18 pi, or that 56.5 number. You're not really going to see one like exactly like this today, but I just wanted to show you that this is allowed with that weird, funky looking cone.